number that goes into both. What goes into both of these?
I believe 2.
2. Okay, so go ahead and divide.
Okay. So
20 divided by 2.
okay, I got it.
Okay, what did you come up with?
Over 14.
10 on the top. What number's on the bottom?
14.
Okay, so get a little bit off there. Let's take a look. You 2 on the outside, 42 on the inside.
Oh wait. Okay, yeah, what else?
So how many times does 2 go into the 4?
2 going to 4 2 times.
2 times. And then how many times does it go into the 2?
2 1 time.
1. Yeah, so that's your denominator.
21. Oh, I put 42 divided by 3, but it was 2.
Oh, okay.
Sorry.
That is for sure 14, but yeah, it's got to be 2.
Okay, sorry, I just got misunderstood here.
All right. Let's take a look here at the next problem. See what you guys, because this was number 7, by the way. Let me label that here in case you want to go back and look. All right. Okay. It says a mirror is in the shape of a rectangle, and it has a length of 7/10 meters and a width of 5/8 meters. Okay. So we want to find the area of the mirror again. So just like in the previous problem, you're going to take the base times the height. So 5/8 times 7/10. All right, so can you multiply those together for us, please?
Okay, so the bottom is 80,
Okay.
and then the top is 35.
Okay. And we're going to divide each of these by a number. Now, does 2 go into both of these?
I believe so.
So 35 is odd, right? 35 is odd. That does not work with 2. So it's got to work in both. So it doesn't work for 35.
Can it work for 5 or no?
Yes, 5 works in both. Let's try that. So I want you to divide both of those by 5, please.
Okay. Okay. Okay, I got my final answer. I also typed it in the room chat too.
Oh, thank you for doing that. Yeah, so 35 divided by 5 is definitely 7, and 80 divided by 5 is 16. Perfect. The notifications on the chat actually don't appear while we're in the room unless I'm like looking at them. So it's like,
Okay.
well, it's unfortunately like sometimes you'll message me. I'm like, I didn't know because it doesn't show up. But that is correct. Very good. Okay. New problem here for us to look at. It says a bunch of bananas weighs 3/4 pounds, 3/4 of a pound. An apple weighs 1/3 as much as the bunch of bananas. Okay. Do you remember what math operation as much as refers to?
Much as is it the wait, sorry, multiplication?
Multiplication, yeah. So we've looked at the words like of means multiplication, as much as means multiplication. So it's 3/4 times 1/3. Okay, so I'd like you to multiply these together and reduce as much as you can.
Okay. So I give you my final answer, right?
Yeah, go ahead and work it all the way out here. You've done a great job on these, so I'm pretty sure you'll be able to get the answer here pretty quickly.
Okay, I got my final answer.
All right, what did you come up with?
1/4.
Very good. Very good. Okay, so let's look at I'm going to look at a new problem with you. Let's look at 5/6. This is a fraction 5/6, okay? And let's say we multiply the fraction by 2 divided by 2. Can you tell me what that becomes?
Okay, let me just write this down really
Sure.
quick.
Sure.
Okay. Okay, so 10/12.
Okay. And then does this reduce? Can we reduce this fraction?
Yes, we can reduce.
We can divide it by 2 and divide it by 2. And that becomes 5/6. Is that okay?
Yes.
All right. So now let's say I give you 5/6 and we multiply by 3/3. What does that become?
Do I have to work this out or?
Yeah, well, you just want you to multiply the top and bottom. Tell me what goes in the top, what goes in the bottom.
Okay, for the top 15 and then 12. Wait, no. 18.
18. Yeah, very good. Okay, now what if we divide the top and bottom by 3?
5, 6.
5/6, yeah. Okay. Now let's do the same thing here one more time. Let's say we take 5/6 and we multiply it by 4/4. Can you tell me what goes in the numerator?
Yes. Okay, so 20/24.
Okay. And then what if we divide both of these by 4? What does that become?
That becomes 4, 4. 5/6.
Yes. So notice each time, if we multiply by the same number in the top and bottom, what does it ultimately become?
5/6.
So the same, right?
Yeah.
So what is 2 divided by 2 really? What is the reduced form of that?
1.
1. And how about 3/3?
1.
Yeah, and 4/4 is also 1.
Mm.
Okay. All right, so that's kind of a primer for helping to answer this next question. We'll see if that helps. It may not. All right, so take a look at this problem. See if anything makes sense here. If not, that's okay, but go ahead and give this a try, please.
So I do this one on my own.
Yeah, I'm just basically asking to give me, your answer here to this, and we'll talk about what to do next.
I have to give you my just my denominator, my numerator, or do I have to give you like the
Just
full
just
answer?
just give me A, B, C, or D. That's all I'm looking for. This is just a choosing problem. It's not a there's no work to do.
I got confused on this one because I multiplied them and
Okay, so let's take the given fraction 11 over 12. Okay,
mhm.
and let's multiply it by 1 over 11. So that's letter A. Okay. Do you see any pre-cancellations here?
uh
Do you see any numbers that are the same on the top and the bottom?
yes, the 11.
Okay, so they cancel. What's left over?
1 and 12.
Okay, is this the same as what we started with? We started with 11 over 12. Is this the same?
No.
No. Okay. So let's try C. So we're going to start with 11 over 12 and multiply by 4 over 11. Do you see any pre-cancellations on this one?
Uh yeah, 11.
Yes. So they both cancel. And this becomes 4 over 12. Is this the same as 11 over 12?
No.
No, so that's out. How about the last one, D? How about 11 over 12 times 12 over 1? What does that become?
That becomes 11 over 1.
Good. And is that the same as 11 over 12?
Nope.
So that means the answer must be B, but let's take a look at why. So 11 over 12 times 4 over 4. That becomes 44 over 48. Can you reduce this fraction?
Yes.
You can divide both of them by 4. What does that become?
Um 11 over 12.
Good. And that's the way it's supposed to be. All right. Any questions on that before we move on to some new stuff now?
No.
Okay. All right, so let's do this here. We're gonna do what's called converting from mixed to improper fractions. Okay, mixed to improper fractions. So let me give you an example. Let me give you something like this: 2 and 1/3. Okay, so here's how you convert this to an improper fraction. You take the 3, which is on the bottom, you multiply it by the number in front, and add 1. Can you tell me what this results in?
Yeah, 7.
7, and then you divide it by the bottom number. So let's do another one. 5 and 3/4. You take the 4. The 4 is on the bottom here. You multiply it by the number in front, which is 5, and then you add the number on top. Can you tell me what that becomes?
Yes. 23.
23, and then you divide it by the number on the bottom, which is 4. Okay, so I want you to try this one here on your own.
Okay.
And give me your final answer, please.
Okay, I got my final answer.
Okay, what did you come up with?
I came up with 7/2.
Very good. Let's have you try another one here. 2 1/4.
Okay, 9/4.
Very good. Just a couple more here because we're going to be doing this over and over again. Just want to make sure you got it
Okay.
all down.
Okay, 14/3.
Yes. Yes, really good. All right. So let's do a new problem here. This is from lesson 5.8, which is upcoming. And let's see what we got here. So let me snip this problem in. Okay, this is, yeah, 5.8 here. Okay, so the start of this problem is that they want you to convert both of these numbers to improper fractions. So can you do that for me, please? Just give me the two improper fractions.
Improper. Wait, sorry, what is improper mean?
It's exactly what we've been doing.
Okay, so,
It's right up here.
okay. Okay. So I'll give you for both, right?
Yes.
Okay. Okay, I got my final answer.
Okay, what's the first one?
For 2 and 4/5, 14/5,
Good. And how about the second one?
3/2.
Really good. So now you're going to multiply the tops and the bottoms. Okay, so 14 times 3, 5 times 2. Do you have either of those numbers for me?
Yeah, I have 10 on the well,
Good. 10 on
40,
the bottom.
and then 42 on the top.
Very good. This is where you have to decide if you can reduce, and 2 goes into both. Can you divide these for us, please?
Okay. Two. Okay, I got my final answer.
Okay, go ahead. I'm ready.
21/5.
Yes. Okay, very good. All right. So we're gonna do one more today, and then we'll close out here. So this is a new problem here. It says, what is the product? What is the product of 2/3 and 3 1/5? Okay. So 2/3, that's fine. Product means multiplication. Okay. I need you to convert this to an improper fraction for us, please.
Okay. Okay, got it.
Okay, what is your improper fraction?
16/5.
Good. Now you have to multiply the tops and the bottoms. 2 times 16, 3 times 5. So go ahead and do that for us, please.
Okay. Two. Okay, I got my final answer.
Okay, what's your final answer?
32/15.
Very good. All right, great job today, Zoe. Go ahead, let Michael know that I'm all ready for him, and I'll see you Thursday at 3 o'clock. Thursday
Okay,
at 3 o'clock.
also Michael's gonna connect in this computer.
Okay, have him just ask him to say hello when he jumps on, please.
Okay, thank
Thank
you.
you.
Say hello. Hello.
Hey, Michael, how are you today?
Good.
All right, so we're gonna work on your quiz here today, parallel and perpendicular lines, okay? All right, so let's take a look here at your quiz, and we're gonna do it one shape at a time here. So here's your quiz. It says the instructions say to figure out where to drop each of these 5 shapes, you know, whether it's in here or not. It's a little bit awkward the way they've done this, but we'll see if we can do this. So parallel, do you remember what parallel means?
No.
Okay, so parallel is like 2 lines that go on forever but never touch. So I want you to look at these shapes, A, B, C, D, and E. And let's look at A. Does A have any parallel sides? To like, think of the lines as going on forever. Do they have lines that go on forever and never touch?
No.
So these don't go on forever.
Oh yeah.
Like you have to separate yourself from the rest of the figure. Yeah. So those are parallel. Okay. Do they have, do they have, now let's go talk about perpendicular. Do you remember that from last time? What's perpendicular?
That They,
Remember the L that I made?
all right.
The right angle, yeah. Does this have any little boxes in it?
Yeah.
It does? Where? I'm asking, where does it have this little box in it somewhere?
Oh, no.
No, it doesn't. So A is only parallel, okay? Let's look at B now. Okay, I know this is hard to do here, so I'm gonna actually grab it again and we'll look at B on its own. So let me snip that in here. Here's letter B. Okay. So I'm gonna extend some of the lines here. Let me put it more in the middle of the screen here. So I'll extend some of the lines. Like, is that parallel to anything? If you're not
Kinda.
sure, does that intersect it?
Yeah.
It does. So that's not parallel. How about this one? Is this one parallel to anything?
Mm, yeah.
These don't intersect.
Oh, wait, they do.
So you have to sort of visualize the lines extending forever. How about this one here? Is this parallel to anything?
Mm, yeah.
Well, what about this one? Does that hit it?
No.
Well, it looks like it hits it. So you're extending the shape beyond where it is. And I know this is hard to do in this format, but you have to visualize these lines being drawn. Like, how about this one here, this side? Is there any side that's parallel to it that never touches it?
Um,
So those hit, right?
yeah.
So it's not parallel. Okay. So this one's definitely not parallel. Okay. But maybe it's perpendicular. Do you see any 90-degree angles in there?
No. No.
Yes. No. So this one is none of the above. This doesn't go anywhere. Okay. All right. So now let's look at C. All right. Do you see any parallel lines?
Uh, no.
Yeah, I would agree. There's no parallel lines here. I'm going to snip it in again. I didn't realize I grabbed the border. There are no parallel lines. How about perpendicular? Do you see any 90-degree angles?
Yeah.
Yeah, one right up there. So this one right here is perpendicular, only perpendicular sides. Okay. Now, when you do this on your own, I think you have to drag it in there. See, you're gonna have to drag in there. All right, let's look at letter D. I'm gonna snip that in. Okay, here we go. Does this have any parallel sides?
Mm,
Are these parallel?
mhm.
Why are they parallel? What makes them parallel in this problem?
Because they never intersect.
Exactly. So these are definitely parallel. All right. Now, are there any 90-degree angles?
Yeah.
Yeah, there's actually 4 of them. So this letter D here, this rectangle here, it actually has both. Okay. So let's look at our last one there. It's a triangle on the right. All right. Are there any parallel sides? Are there any sides that never intersect here when you draw them out? Like, does that one ever intersect with something, or this one on the bottom, or this one on the top? Do they ever enter? Are there any parallel lines that never intersect?
No.
No. Are there any 90-degree angles?
No.
No. So this last one doesn't fit anywhere. So nothing. on that. All right, so this is the first question on your quiz. I do send you the notes. At least I send them to Dad at the end. So we'll you'll want to definitely get that down here. All right, so let's move on to another question. All right, can you read this out loud for us, please, Natalie?
Natalie must draw a line through point P that is parallel to this vertex line.
Vertical line, good. Okay, so I'm going to draw two lines. I'm going to draw a line in red and a line in green. Which is parallel to the black line? Is it the red or is it the green?
The red.
The red. Okay. Now, go ahead and read this question here, starting with which.
Which other point will lie on Natalie's parallel problem?
Line. So which other point is on this line?
P and A.
Okay, so what's your correct answer here?
A.
It is A. Good. Not too difficult when you kind of know parallel and perpendicular. All right, so let's look at another question here. So we have not covered this question, but I'm going to just see if maybe you've got it down or you're comfortable with it. All right, so it says, what is the name of the bolded part of this figure? And if you can't tell, I'll put it in green here. It's this right here. So is it a line segment, a line, array, or a point? What do you think?
Oh, a point.
Okay, what point is it then?
E.
Okay, so you're saying, I mean, I'm looking at this drawing here too. I mean, here's E, and I don't see that anywhere near this. Do you agree that E is over here to the left and this line is somewhere else?
Yeah.
Okay, so it can't be that. So which two letters are on this?
F and D.
Okay, do you see them anywhere in here?
Yeah.
Where do you see them?
On radi and
Yeah. Yeah, so here's what array is. Array starts at a point and it goes out. This is array. Have you seen that in class or not?
yeah.
Okay. All right, so here is a new problem for you to look at. It says which line is parallel to MN in this figure. Okay, so I want you to do on your screen is make sure you can tell me the line MN, like look at it, put your finger on it. Make sure you know where MN is, letters M and N. Do you see letters M and N?
Yeah.
Okay, so I'm going to shade that line right here. I'm shading that line. So which one is parallel to that? Which one never, never, never touches it?
M and A.
Where is A?
I mean N.
Okay, it can't be the same line. I mean, we're asking for the one that's parallel to this. Parallel means it's a different line, but it never intersects.
Okay. So J,
A line has two letters. Do you see how all three answers have two letters in them?
J, K.
Okay, so let's take a look here. JK. KJ. So here's JK. Now I'm just going to extend them. Okay, right? You just extend them. Do they ever intersect? Now you play video games, right, Michael? Michael?
Yeah.
Okay, when you're playing a video game, if you're running, if your player is running this direction and the other player is running this direction, are you guys going to intersect?
Yeah.
Yeah. But if so, you got to think of it that way. So these are not parallel, they intersect. So try again. Which two lines never intersect?
Uh, L and K.
L and K. Let's take a look. So here we are. Keep going. Are those going to intersect?
No.
No, they don't look like it. It's just like in a game. If you're running this way and the other guy's running this way, you guys never intersect. Okay. Yeah, so that is that's the correct answer there. Good. Hopefully that's now clear. Perpendicular. So next problem here looks at perpendicular. So perpendicular means they meet at a 90-degree angle. Which line is perpendicular to line MN? So perpendicular means that it meets at that 90-degree. Okay. It's almost the exact, it is the exact same drawing as the previous one. So MN is down here. Which line is perpendicular?
Okay.
Okay, so let's try that again here. Let's go ahead and diagram here. Line MN, there's MN, like that. And you said which one?
KL or
KL. Okay, so there it is. KL. Are those perpendicular? Do they meet?
No.
Nope. So it's definitely not that one. Those are the parallel lines. Those lines are parallel, just like in the previous problem. So what lines are perpendicular?
L, wait, JK.
Okay, so here's JK. Let's do that. Here's this line. So these definitely intersect, but do they meet at a 90-degree angle? Do you see a little box there when they intersect?
Hmm. Yeah.
You do? Where's the box?
Wait.
I don't see a box there. Perpendicular means they've got to meet at the box. So the answer must be KM, but let's see why. Here's KM. Do KM and the green, is there a box there where they intersect?
Yeah.
Yeah, well, that's what makes them perpendicular. So that's your correct answer. Does that make sense between perpendicular and parallel?
Kinda.
Okay, so are these lines parallel or perpendicular?
Parallel.
Good. And are these lines parallel or perpendicular? I'm sorry,
Yeah.
which one? What are they on the right? Is it parallel or perpendicular?
Right.
So perpendicular means right. Okay. All right. So what's interesting is they actually double up and give you the same question again at the end. This is question 8, which we've already done. So I'll just snip that in here real quick. Okay, so this is number 8, and this is the same as number 1. Don't know why, but that's what it is. All right, so that's going to do it for us for today, Michael. So thanks so much for letting me help you. We got another lesson on Thursday at